That one is.
Try and stand away.
Yeah. There you go.
Everybody here? Okay.
Let me just squeeze behind you.
Absolutely. We're going to go ahead and get started with. So as we go, feel free to go grab some food. You can just come in now. Help yourself. There's plenty of pizza there, plenty of drinks. First, I'd like to welcome you to the New York City Revit Users Group meeting number 3. And I'm happy to say that looks like pretty well these last 2 meetings. If you've been to a couple of meetings before, usually it's not me standing up here. It's usually James Vanderzand, who's kind of our president right now, but he's on vacation this week. So my name is Chris Dude. I am a digital design specialist here at SOM. If you remember from last meeting, we were doing a presentation of the projects we were working on. So let's stand apart. So we're not in the way here. But so I'm going to keep this, kind of short and simple. We have a great speaker tonight, and we're kind of on a tight schedule. He has some travel arrangements that he's got to get out for. But after his presentation, we'll make sure we do some question and answer, and some general networking and a few other things that we have. So let me check my notes here. I don't have any announcements. James usually has a whole slew of announcements and everything, but I don't have anything to tell you guys other than I'm glad everybody's here. I'm glad to see a lot of SOMers here, obviously. I'm thankful to SOM for letting us use this space, and we will have this space available to us if we want to use it, but I ask you if you guys have some space at your office or know of a space where we can host these meetings, we'd be glad to have it. We'd also be glad to have other topics and speakers. I know there's a lot of projects that's going on right now in Revit in all your offices, and I'd like to see, we'd all like to see it. So any kind of future topics that you might have, we'd really love to hear it. So I guess without further ado, I'll introduce Wesley Benn. Wesley and I kind of go back a couple years now, from various things. We met at Autodesk University. He's a good friend of James Vanderzand's and mine. And when we heard he was coming through town, we kind of roped him into coming to this meeting and giving a nice presentation for us. So a little history about Wesley. He's been in the architectural industry for over 20 years now. Owns his own firm, has for the past 7 years. And over those 7 years, they kind of grown from just a 1 or 2 person shop down to about 13 people, which sounds small, but for Australia, that's actually a medium-sized firm. Around there, so I'm told. Now, not quite as big, but Wesley's been doing not only architecture, he also runs CAD consulting services and has really close connections to Autodesk, especially Autodesk Revit, in developing Asia-Pacific content, right? And kind of localizing it for the Australian market. So he's got a lot. He's been a pioneer in the use of Revit, especially in the Australian market. So it'll be interesting to see just what's going on across the continent, well, across the world, over in Australia when using Revit. So, Wesley's also the chairman and founding member of obviously a local Revit users group out there in Sydney, which has been in operation for 3.5 years, longer than ours, much longer than ours. I hate to say, especially since we're in New York, we should have been doing this a long time ago. Wesley also, you're an instructor now, right? A teacher now at University. What is it? University of North South Wales, and does a whole Revit Technology Conference series, and he's a regular speaker on various, I guess, architectural seminars and things like that. So, with that horrible introduction, I apologize. I might have killed that for you, but please give a welcome to Wesley Benn. And let's see what it is. I'm going to move.
You're good. Thanks very much. I particularly like Chris's bit about coming to give you a nice presentation, so I try not to give you a horrible presentation because the reality is I haven't really thought this through particularly well at this point. There's 2 basic things I thought I would tell you a little bit about this evening. Unfortunately, we are relatively limited in time, so I appreciate everybody also being willing to leave work early because I know how hard that must have all been on you psychologically. So the 2 things is I just thought I'd show you a couple of images, a couple of projects that are happening in Australia. And then one of the things that part of the reason I'm traveling at the moment is related to some work I'm doing with organizational transformation. In other words, looking at the way we can change the process that the AEC industry uses to try and reduce waste and inefficiency. As Chris mentioned, I have my own practice. In Australia, 12 people, 13 people is a medium-sized firm. The average size firm in Australia is just under 2¼ people. And to give you a sense of scale here, the continental United States and Australia are roughly 10 square feet difference in land mass. I mean, it's remarkable how close they are in size. New York, greater New York, is larger than the combined populations of Australia, New Zealand, and Canada. Okay? So that gives you a good idea of the difference in market size that we're dealing with here. And in Australian terms, a big firm is something that's over 70, 80, maybe that sort of size. That's considered really quite a big firm. And the biggest firms are 500, 600 people. So you're not going to get projects happening in Australia of the size of things that you're seeing a lot of. Well, for instance, the Freedom Tower that SOM is working on, obviously, that I saw today. But a lot of the bigger Australian firms are doing work in Asia. I mean, the growth markets obviously are the Middle East and China. So there's a lot of big projects happening in that sort of area. The types of projects that my practice does is mostly residential, medium density. So we do a fair amount of apartment work in the 30 to 150 apartment sort of size. We do reasonably high-end residential work, housework. We do occasional more fun projects like this one here, which is a yacht club. And I find it's not terribly often that we get to really spread our wings and play, because money, obviously, with everybody is obviously a big problem. But nevertheless, we do have, we've had a couple of projects of this nature, and they're the ones I try and hold for myself. But this one here, if I just skip this forward and see what we've got. This one here is the previous one, which people like Chris would recognize, which is a childcare center in Shanghai, which was the previous one where we'd really gotten to just play with it. It was part of a project called Celestial, which was a very large town planning project. And as part of the requirement, the design council said that they must have a childcare center, in this case capable of taking about 250 kids, and a community center also. And because they were building 11,000 apartments, 6,500 houses, and the appropriate amount of commercial space to go with it, budget, they really didn't care. They just said, look, here's the land, do something and let me know when it's ready to build. The other extraordinary thing about that is that it's actually been built now, and they built the entire thing in about 9 months flat. It was an interesting project in Revit terms, and depending on how quickly I go through my material, I might actually pull that file up, because the building, as you see it, there's only about 5 days past butter paper. And it was actually done by a fellow in my office, Adrian, who was the first time he was in Revit, so he had to translate the ideas into the building and put the file together. So I was really quite impressed with that. And then there's various other things that we're involved in, and some of the things we do. This is a rendering process that we did as part of a demonstration for another firm, because my practice now is not a pure architectural one. We really have 3 business units, and most of the people cross over a bit, which is our architectural work. We do production work, which is drafting and outsourcing of work for other companies that lack the skills, resources, or just time to do the work. And we also do, as Chris mentioned, technology-based work. So we do training and implementation of Revit. We do support services on behalf of the local distributors, and also now on behalf of Autodesk themselves. We build the Australian content that ships with Revit, and we do various other bits and pieces of that nature. So not all of the images you'll see in that slideshow, for instance, that was running at the beginning, a lot of that's not ours. But it's just a reasonable slice of some of the things that are happening in Australia. So if we jump to here, eventually, this is that Yacht Club. It's on an island. It's on an island called Hamilton Island, which is on the Great Barrier Reef in sort of northeastern Australia, off the coast of Queensland. The building itself is based on a particular flower, the Hanalawa, which is indigenous to the islands, not found anywhere off the island, which is interesting because the island's only about miles. It's only about 15 miles off the coast, and yet somehow these things have never translated onto the mainland. So just to have a very quick look, because I don't want to take too much time into this, but this was a project I had particular fun with, so I thought I would show it. As I said, it's a yacht club. I'll show you some images from it as well, but this section of the building is actually sitting on a little spit of land that extends out this way, and the bay is on this side, around here, but this side here is exposed to the Pacific swell, and so you can get, in moderately stormy weather, you'll get waves that are, still try and convert everything to imperial. Right inside the lagoon, you'll still get 12, 15-foot waves. So this, the base of this wall, as you can see it in the model at the moment, is only about 3 feet above sea level. So it gets hit quite a lot, and so it's got to be quite a strong object. But the interesting thing about something like this is it looks like quite a complex, the roofs in particular look like quite complex objects. And in fact, if you pull up one of these things and have a quick look at it, in fact, it's very, very simple. What it is the green form is just a roof by extrusion, this shape here, running back to the building. It's then broken from the work plane on which it was created and tilted, and then simply a void shape is used, a void shape in like a donut, so that it's removing the outside, is used to leave us with this sort of leaf form roof. So in fact, it's actually very simple structurally, and that's one of the main things try and do with a lot of these buildings, like that childcare center where all of the walls are curved and canted. A lot of them have holes cut in them and all sorts of weird things. The building itself is actually just sitting on a rectilinear concrete portal frame, and all of those fancy bits are really just cladding. So relatively easy to build. Same sort of thing here. The interesting thing about that is it does lead into the other portion of the discussion I wanted to have, which is about process change, because we're having huge fights at the moment with the engineers trying to say, look, it's not that hard. This is not something that you can't do. And they're coming along and saying, well, it's impossible to build that. So we took them over to another site and said, well, there it is. And they grumbled and didn't talk to me for a few days. But this particular engineer, unfortunately, we didn't get the opportunity to actually specify the engineer. And in fact, he still works with pencils and doesn't computerize his drawings. So he's rather behind the times, particularly as where I'm trying to go with practice in general at the moment is to the point where everybody is using a consistent and coordinated model across disciplines. So it's this one, unfortunately, as much fun as the building's been, is actually, I suspect, going to be a very painful construction process. The images from that one, if I just jump forward to some of those images, right down the bottom. So this is the site here. You can see the spit of land running across here, and this is the little walkway with a cafe on the end. There's a lagoon and reef area just out here, but the waves get strong enough during storms to actually breach it. It's one of the problems, in fact, that Australia's got with the Great Barrier Reef at the moment is the amount of damage that's happening to it because of storms and because of pollution, that this sort of thing is actually starting to erode the reef much faster than the traditional growth cycle's been. But this project here is the Yacht Club and the series of bourrées, which is the, well, these aren't traditional by any means, but this, a series of houses that run along the access to the site. One of the difficulties we've had with this site is the slope here is on average about 30 degrees. And in parts of it, it's over 45 degrees. So getting roads running along it, even getting ramps into the front of the yacht club's been very difficult. That's just a play with some of the roof connections to the outer wall. Don't know why that one's in there. The deck off of the dining room on the upper floor. This is out from the cafe on the little spit of land looking back. And you can see that in this one we've got the original roof shape, which was when the flower opens and closes every day. So this is what the flower looks like at about 10 or 11 o'clock in the morning. By about 6 o'clock at night, it's folded back downward to look like more like that. And that's what we've ended up with. It's just a lot easier form to work with, in fact. One of the interesting things about Hamilton Island is that it's big enough to have golf carts, but not big enough for cars. And because of a lot of the slopes on the island, the golf carts, you can wear your golf carts out very quickly, the brakes. You can get red hot brakes in a golf cart's an interesting thing to see happen. But they had a requirement in there, which we're still fighting with, to actually take the one car that's on the island, which is a stretch limousine for use in weddings, and have a driveway that got them up to the front entry of the building and back down again. And nearly the full width of this spit of land was going to be required to do it. And where we've gotten to at the moment is we actually have a turntable at the top to get the thing spun around so we can point it back down and out again. But we'll see what happens with that. So yes, as you can see, you come up this side, and then for golf carts can make it around here, but this big car couldn't, so we'll turn it around on the turntable. It's the entry lobby area. This is a yacht club with far too much money. Oh yes, that's the original roof and the later roof. So you can see here with the actual water level, when a big storm comes in, I'm not sure if we're going to, if these windows here are going to survive, or they're going to be very, very thick. Because again, that's a, inside there is a 25-meter lap pool, which will be the only one on the island, which is quite surprising. But the bottom of the pool itself is actually just below sea level. So we're tanking and waterproofing a swimming pool, which I don't think actually to keep the water out before we put the water in. Yeah. All right. Oh yes, my safety officer photos. That was on one of my sites. He didn't last very long, but fortunately it was because he was sent away. So that's just a very fun project that we did. This one here, I think that's about revision 61 for that building. I don't know how difficult local councils or government authorities are here. That was a project that we've just had approval, design approval for. So I guess DD approval. 3 years and 1 month it took to get that through local government. That's not exactly a complex or original or sophisticated building. So I presume you have the same sort of hassles here as we do with that, but the amount of controls that are required is quite extraordinary. In fact, that one was quite interesting because when we first started looking at the site, we had the local code for that site which allowed 7 stories. The client wanted 7, and about a month after we started talking about the project, new codes came out that had been first revision in 8 or 9 years, and it allowed 17 stories. So the client said, okay, well, let's do a 17-story building. The problem with that is it meant we were the first cab off the rank. And the council saw the 17-story building and got really scared. The other problem we had was that this particular council, called Liverpool Council, had been stung twice in the last year or two before this. The first one was fraud and corruption on the council. So the council had actually been fired and replaced with an administrator. So they were running scared of all sorts of things at that point. And then they'd gotten in trouble again with a development which was a large warehouse-style or bulk goods retail outlet, which I have no idea what it'd be in square feet, but it was about 80,000 square meters. So it was pretty large. And 2 months or so after they moved in, Frank Lowy, who's the head of Westfield, and therefore to whom this was a competitive project, said, guys, you realize that that land's not actually zoned for bulk goods retail. And rather than doing what the councils would normally do, which is retroactively approve it, council shut it down and kicked everybody out. So of course, lots and lots of very expensive lawsuits, councils running scared. So in the period between that second event happening and this building going into council, which was about a year, 2 houses were approved in that entire local government area. No commercial buildings, just 2 houses. And then we come along with this building, which is sitting next to a series of 2- and 3-story very old commercial buildings, and scared the hell out of them. Eventually we got it through, but it was via the Land and Environment Court, which is the court process in Australia for building type projects. If we've got a few minutes extra, I'll come back and I'll pull up a couple other files, because the one thing, as I mentioned, that I wanted to talk about was this. We use Revit end-to-end on our projects in our office. So from massing studies through to construction documentation, as-built drawings, all of that sort of thing. We've gotten involved with a few of the clients that we work with through our technology side of our business in facilities management with Revit. For instance, one of them is Woolworths. Now, in Australia, Woolworths is a supermarket chain, just foods. They're the biggest supermarket chain in Australia, and we've converted them across to Revit. And what we now have is a system in place there where we can go in and tell you how much electricity is required by the bakery, how much water services are required by meat prep, and whether the shelf space for dog food in Albury-Wodonga is more efficient than that in Melbourne in 1986. Right, so all of that sort of information we can actually pull out of the Revit models. So we're starting to we're pushing where we can use that model. But nevertheless, that still is really, other than that last step, which is fairly isolated to what we've been doing with Woolworths, it really is a question of doing these things within your practice. Gaining all of the advantages that Revit will give you in doing your architectural work. Now that's fabulous and that's great for us, but in the end it's not taking real advantage of where this process can and should be. And looking at some of the material that's been developed, a little too close, over the last few years, starting to talk to various people in the construction industry about this, I've been starting to play with ways that we can carry the ideas that Revit espouses in terms of taking certain aspects of your workload off of the plate, looking after design relationships for you, doing drawing management for you, and carry those ideas, you know, how best to leverage technology into all the other aspects of what we do. Now, the first and most obvious place where that's occurring is in the stratification of Revit, so that now we have Revit structures that people are using, Revit systems, which is a released product here, isn't it? It technically is not released actually anywhere outside of the United States, although there are a number of people who are starting to use it anyway. And that's allowing us to get consultants working with the software, and so that we can get the same sort of information from their documents as from ours. So the next step there is using the copy monitor system, which is effectively linking across services or across consultants to best utilize that information. But even so, that's still really only one step down the track. So what happens if you try and look at the end-to-end process? So the people we're missing out here are your general contractors, your fabricators, the owners and managers. So full life cycle examination. And I had a look at some data that the National Institute of Standards and Technology, NIST, which is an American group, have put out. And they did a survey, quite an extensive survey, 2 years ago that looked at some of these issues. And what they found was that across the building or construction types that you see here, you've got roughly $375 billion of work being done. Now that's 4 years ago, and that does not include infrastructure, so no roads or pipe systems or anything of that nature, and it does not include any residential work. So this is purely commercial and industrial. It's $375 billion in the United States. Now, of that, what they discovered is that roughly $15.8 billion a year is being lost in inefficiencies caused purely by, what was the phrase they used? Another one of these nice long phrases, inefficiencies in interoperability. In other words, purely in the relationship between the architect and the other consultants, and then the transfer of that knowledge over to construction. Once you get then past that into the actual life cycle of the building, it gets a lot worse again. So the basic process that we're running through here is this one here, the life cycle. Plan and design is very short at the beginning. Construction and commission, not that much longer. You've got, hopefully, a very long life cycle to run through the building, and then you've got decommissioning. And when you look at a chart like this, what you're seeing is, if we decide to make a change to the building here, early on in the planning stages, there's virtually no cost to doing that. As we're getting up into conceptual design, you take a little jump, you take another jump as you get to detailed design, etc. So the later through the process you leave the changes, the more expensive they are. And when you then, if you were to then take this data and translate it into here, what you find is that this section here is compressed into this little bit. This guy here is in here, and then the tallest one is in the period which is the vast life of your building. So you're likely, as changes occur or inefficiencies are identified that need to be remedied in the life of the building, you're going to have a very high cost involved in doing so. Then over here is my little personal chart, and I don't know where that went. I think Chris pulled it off my computer this afternoon. What that is the traditional process that we go through in the AEC industry is the architect gets a piece of paper and he starts scribbling. He starts from a base point, and I'll just sketch it in the air. Starts from a base point, builds up the knowledge level as the design is developed. Gets to a certain point, sends it over to the structural engineer perhaps first. Structural engineer builds it up. It goes off to the other consultants. They build it up. It goes off to the owner for life cycle. They build it up. Then it's decommissioned. So it's a very, very inefficient way of transferring knowledge, because at each of the steps, the next person in that process has to start almost from scratch. And what we want to try and do is put together a system that allows us to carry the information in a much simpler curve. So that one's, no, this here, sorry, is the impact in dollar terms of that wastage, that $15.8 billion wastage that I talked about. So just to have a quick look at that. What it's showing us is that, first of all, through the different phases, the architects during planning and design, there's about $1 billion there, but in total only about $1.2 billion of that 15.8. Contractors and fabricators only about $4 billion, which leaves the owners and operators to deal with $10.5 billion worth of cost from inefficiencies. The reason for that, again, is if we look back at the life cycle chart, most of our cost and most of our problems are going to occur across the 30 to 50 years the building's in existence, not the 3 years prior. So documents, charts like this, what they're doing is suggesting that if we can find a way to make owners and operators of buildings recognize questions of efficiencies, and you put 2% extra money into year one, you're going to save 20% down in year 25. That's really where we need to try and get to. I don't see that we're anywhere close to that. I don't see that it's going to happen anytime soon either. But to my point of view, it ends up being a fairly clear argument that a little bit of extra time, a little bit of extra money at the front makes huge savings downstream. Now, I think that is all. I'll come back to that. In order to then experiment with what are the actual methods we can put in place to test this as a hypothesis and to try and build new systems, build new processes, we have this little project in Sydney. It's a rather confused one because the client is the government of New Caledonia. The project manager is in Melbourne, which is about 800 miles south of Sydney. Of course, we're in Sydney and the project's in Sydney. But it's a fairly small project. It's probably going to cost about $3 million. It's a very simple building. None of the forms like that Yacht Club project, just rectilinear. It's only at most 3 stories tall. It's got a heritage building at the, well, it's got a building that's considered to be heritage interest, which means it relates to items that are heritage listed in the area but is not listed itself. On the front of it, it's a relatively constrained site. But because it's quite simple, we've kept the structure very simple, it's given us a good little platform to use as an experiment. Now, what's happening with this project? And hopefully in 3 or 4 months, whether at Autodesk University or afterwards, I'll be back in the country, and because there's a couple people who want to see some results from this, because that's what I can't offer you right now. What we've done is we've put together a design team which is, in traditional terms, the consultants. In other words, every week at the moment and every 2 weeks into construction documentation, architect, structural, mechanical, electrical, fire, BCA, which is the local Australian building codes, the builder, and on occasion fabricators all sit down together in a design meeting. And so I'll come along, or someone in my office come along and say, wouldn't it be nice if we could just cantilever this? And the engineers say, yeah, sure, if you want 2-meter deep beams. And the builders say, yeah, if you're dumb enough to spend an extra $600,000 on it. But then someone else will turn around and say, but if you want that effect, what about doing X? The result is that in traditional terms, if something goes wrong in a building, the structural beams aren't big enough and we've got to change the design to accommodate it, the architect's going to turn around and point the engineer. But the engineer's going to turn around and point the mechanical guy and say it's because I had to get around his stuff. And the mechanical guy's going to say BCA required my stuff. And everybody's pointing their fingers. So it becomes a very adversarial process. What we're looking to do by building a team of this nature is two things. One is ensuring knowledge transfer happens efficiently and very, very quickly. And the other is build a team where people aren't looking for blame, they're looking for solutions. Right? If we invest everybody in the design process, if we get those people involved in saying, well, why don't you try X from a design perspective, then when a problem does come up, people will sit down and say, well, what do we need to do to make this work? So that makes things faster. It makes the transfer of information, as I said, much better. It also means that the knowledge of that project, everybody has shared knowledge. So we're smoothing out that invisible graph of mine. And therefore, we're talking about faster construction times. We are talking about lowered variation costs on site. We're talking about situations in which decisions that we as architects make have been vetted through the consultant process before they become hard to change. So all of these things, theoretically, should make a big difference to the way this all works. And that is the real question here, because unfortunately, yes, it is theoretical. When you go back and you look at some of the documents about waste and inefficiencies, the comments that come out of that process are these. First of all, the most obvious is we need improved communications between stakeholders. To my mind, get everybody together working as a design team. The architect to provide continuously updated project information. Well, in this situation, or in this example, that can be read two ways. One, because we've got these meetings every week, well, every week people have this information. On the other hand, it also means that, particularly with a product like Revit, where you've got very big file sizes, that to transfer that information around, email just ain't going to cut it anymore. So it means almost certainly a web-based document transfer system. There are a few out there. We've been experimenting with Buzzsaw from Autodesk with Groove Networks, which I think has been now owned by Microsoft. Not sure. There's a couple of these web-based systems out there, and essentially they're FTP sites, file transfer sites, with fancy front ends for helping with document transmittals and email and things of that nature. But that means that you can, at the end of the day, upload your file to that site. When you come in the morning, you grab the structural engineers and the mechanical engineers' files, reload them into yours, and see where everything is, so that you've got, at the minimum, a daily transfer of knowledge between all of the team members. Implement software to integrate data and information standards, which actually also relates to this one here, electronic document management, and really to this one, manage and organize correspondence. Now, a web-based system such as Buzzsaw does certain aspects of that. We've also put in place a program, and I think I've turned off the server that runs it, but a program called Archetype, and there's a number of competitors to it out there on the market, but Archetype is a practice management system. So it looks after our email, our contacts, our calendars and timesheets. It looks after our billings, but it also then goes through and looks after our contracts, all other forms of correspondence, agendas and minutes of meetings, everything, every type of document that we use in a general architectural project runs through this, and all of them are then tracked by which project they're related to. So that if I'm on the phone and the engineer, you know, in the old process, I'm going to point my finger at him, the engineer calls up and says, look, I told you in an email in May that you couldn't have that cantilever. I can actually just pop in the system, just pop engineer May email, and up will pop the 6 emails from that person on that project, which means while I'm on the phone, I can say, well, no, you didn't, or yes, you're right, I see it. That was probably part of what caused me to first get into this process, because I had a project in Sydney where, and it was just a house, but the project from first design to finish and construction was about 6 years. Because I was a sole practitioner when it started, I did the initial design work. Then I gave it to somebody else who came into the office because it wasn't in Revit, and I'd moved to Revit, and I didn't want to deal with Vectorworks anymore. Then they left, and I looked after it again for a little while and gave it to somebody else. Everybody has their own little ways of naming documents, of storing documents, filing pieces of paper, everything else. This particular builder, I would not recommend this builder to somebody I hate. He would always write documents that were deliberately vague and inaccurate, so that if I were to call him up and say, look, you can't, that's not what was agreed and that's not what you have to do, he would argue it, and it turns out the paperwork was always great. And what I was finding on that project was, when I got in an argument with this guy, which was happening at least once a day, I didn't have a paper trail that allowed me to turn around and say, yes, you have to do that, shut up and leave me alone. So something like Archetype or its competition, that's, well, it's not necessarily about telling people to shut up, but it's about having the paper trail accurate and easy to work with. And it ties back, it's doing really the same sort of thing as Revit. It's saying, let the theoretically logical computer do as much of the work for you as possible so that you don't have to. That's a big thing about Revit for me, and that's the thing about something like Archetype. That's the thing about using something like Buzzsaw as a transfer system. It's all about leveraging that technology to give me the best and simplest way to get to the point where I can turn around to the client and say, Chris can build you the building for $3 million, and I'm sure it'll be lovely. I can build you the same building and it'll be lovely, but it'll only cost $2.5, because I can turn around and remove all the inefficiencies from the system, and I can get you into that building 6 months faster, because everybody who's working on the project is going to understand the project and everybody's invested in that result. So a couple other things here. Talks about neutral file formats. Can't see it happening, to be honest with you. There are things like IFC. IFC is quite interesting. We've had a fairly extensive play with it, because in developing the Australian content for Revit, one of the things that happened with Revit 9 was IFC parameters had to be fed into a lot of the basic families to allow users to start to play with it. And what we found was that the parameters that are available as part of the IFC system are not as extensive as the parameters that you can have in Revit. So that if you have a door, the IFC can understand single leaf, left opening, single leaf, right opening, double leaf. And that's virtually it. And that's not really enough of a description, given what you can do to that door in Revit. We've had good success with transferring a Revit, an IFC-based model to other companies and getting a very good model, but we're not carrying across the depth of information that Revit's model has within it. And for companies like Autodesk, for Revit, they don't see any competitive advantage in opening up their file formats. You know, that's where they see their money coming from. If they open up the Revit file format, everybody will just start reading and creating Revit files, and they think they're going to lose money. So I don't believe that neutral file formats are possible. I do believe that IFC or something of its nature can eventually grow to the level of sophistication to at least allow us to work reasonably seamlessly between Revit and ArchiCAD and MicroStation, Triforma, and other, not ADT, and other products of that nature. Minimize use of paper, electronic signatures, data, the use of handholds, things like that. Again, for us, with the use of Archetype, well, we don't have very much that's printed out anymore. Even letters that come in through the post, they actually get scanned and then go out to whoever needs to see them. They don't need to be printed again, and if you need somebody else to look at it, a little task created that is linked to that document so they can pull up and have a look. So our usage of paper has dropped by a little bit over 40% in the last year. Now for us being 12 people, that's great, but if you're an office of 100 people or 500 people, it's a rather different question again. My office thinks that I have a printer fetish. I think we have 8 printers at the moment. Does anybody want to buy an Australian printer? But we need to get rid of some of those. So we actually don't use nearly as much printout as we used to. RFID, that's an interesting one. The idea of using radio frequency tags to track components, whether from a facilities management point of view or from a construction point of view. Again, as builders themselves start to get more into this process, that's going to make a big difference. And again, that's going to carry straight into facilities management and therefore life cycle management, life cycle cost management. And that's really it from that material. It is a very, very quick overview. And as I said, this is really an experiment. We're also looking at things like, which I believe eSpecs is a product here that a number of people are working with, at the process of getting specification writing built in to Revit so that we can work with it direct from our model. There is code checking systems that are starting to show up. Singapore has got the best example of that. That again, if we can attach all these things to the model, that will make a huge difference. So I would hope that 4 months from now I'd be able to turn around and say, this is our analysis of a traditional project of this size, a $3 million, fairly simple style $3 million building, and the schedule that we need for that. And here is the changes that we've seen. So we have a lot of analysis to do over the next, well, 3 months and also over the next 15 months as we get that building built. But certainly, even in the initial design stages where we've brought the consultants in as part of a design team very early, we've seen a lot of problems crop up, a lot of issues crop up that are going to crop up in a building under any circumstances, but we've seen them early on in the design stage and we have them resolved. And that means that when we get into construction documentation, we're not going to have to worry about cutting holes through steel beams to run a duct and doing things of that nature, because that's already been seen and already been dealt with. And I think that's going to be really the very big change, or the second level of change, that building information modeling will bring us to. So I apologize for it being relatively quick, but I think with 15 minutes or so left, if we wanted to just throw it open to questions or comments, I can show some more images and things if people are interested. So thank you for listening to me.
Wesley does have a pretty tight schedule, so we'll do question and answer with him, but feel free to stick around after he has to go. There's a lot of Revit knowledge in this room, so if you've got a burning question or something, make sure you talk to each other. There's a lot of people that know a lot about the software and have been using it on every day, and so I encourage you to kind of talk to each other and work things out. But for now, let's, we have any questions for Wes, would be welcome for sure. Very impressed with that pedal project. I don't think I've seen that.
Yeah, no, that's a new one. That's a new one. It only actually went public a few weeks ago. So
that's great.
Yeah.
Revit with images of materiality?
The Revit will work. Sorry, you just mean in rendering terms, getting something that's relatively realistic? Two responses to that. The first is Revit can create some very good renderings, and the renderings of the Yacht Club, for instance, you saw, other than the fountain in that front image, which we faked in, they were entirely inside Revit. But if you're going to create a large series of high-end renderings, you should take it out, take the model, develop it all in here, but then take it out of here into something like Max or one of the other rendering programs, because Revit's renderer is wonderful in its simplicity and in its connection with the model. I mean, I've built a model, I can turn around and hit render and get something without having done any work at all. And with a little bit of work, I get really quite a decent result. And as I modify that model, I can get instant updates to, depending on the computer, to the, yeah, very relative term, to that model. But AccuRender, which is the rendering engine built into Revit, is not nearly as sophisticated as something like Max. The main difference is being Max's engine, and that's probably the most common other system for rendering. Max's engine is much faster, and it's also a much, much better lighting model. So, and it's amazing what a difference getting the lighting right makes to the rendering. I mean, it's really the primary impact on a rendering. So if you've got to do a whole bunch of really high-end stuff, take it out to Max. Now, the other aspect of that is just in terms of getting materials in there. You can use a JPEG image. There's a, I don't know what you'd call it here, but a dry stack slate wall. So just a stacked stone wall that's down the road, you like it, take a photo, bring it back to the office, you can use it as a Revit material. Within that material definition, you can add a bump map to it, which gives it some roughness, some texture, and have a rendering that uses that in 10 minutes, less. So it is very good for that, but it's not, you know, you're not going to print a A1 high definition image from an AccuRender rendering and have it feel real. The other side of that, of course, is a longer term question, which you can't really go into. How photorealistic should you try and be? This is a computer image. Can you ever get it so that people have no way of knowing? And if you're going to try and make it look like it's real and just barely fail, to me, that's worse than not trying that at all. So, yeah.
The images that we saw, were they combinations of Max?
No.
The interior, what's the end of it?
From the Yacht Club? Yeah.
I didn't think they were Revit images either. So.
Okay, that one is not Revit. These are, that's not. This is Revit, that's Revit. Yeah.
With some Photoshop work.
Yes, that's got some, yeah, the unfortunate part, of course, is that you can't deal with the foreground image inside Revit, but that is, these are all Revit images.
That's great.
So, yeah.
There's been some rumors that the next version of Revit may have some integration with the latest release or the next release of Viz. Do you know anything about that?
Yes, and I'm not allowed to tell you that unfortunately you're wrong. No, there's a lot of, it's not in the next release. Okay. There is a lot of talk about when it will happen. There's a lot of assumptions, and I don't know the answer to that as opposed to not being able to tell you. But there's certainly a lot of logic to them doing it. I mean, when you look at it in simple terms, AccuRender, they pay a royalty for every single license of Revit that's sold. And they don't talk to the developer either, or the developer doesn't talk to them anymore. It's not a happy relationship. And of course, Viz and Max is owned by Autodesk. Right. So the logic's there. On the other hand, you look at how you use Revit and the simplicity of its interface and method of operation, and then you look at Max, where if you open all the little buttons down the side, it's about 12 feet long. And how they go about converting that process to Revit's logic and ease of use is going to be a big trick. Once they eventually get around to the process of going to the 64-bit systems, which is going to happen some point, they're going to have to do a major rewrite of the program, and I would say that's when it's likely to occur. So, yeah. Oh, sorry. Yeah.
Well, you can go ahead.
Trick question, but I don't know.
Blue.
The way this technology is going, it seems as if AutoCAD is a very bland drafting type tool, which I don't know where Revit is needing?
AutoCAD's great advantage and great disadvantage is that it's, I mean, if you use the word bland, it's that it's generic. You can use it for architecture, you can use it for designing printed circuit boards. And because it is a jack of all trades, it's a master of none. So the architectural industry is certainly moving towards a much more industry-specific system because of all the advantages you get out of that. So, yeah.
I was just wondering if there's any current thinking on the complexity problem, that in Revit models we're just scratching the surface of the actual complexity of buildings, and it's very much bogging down the software and the,
yes.
and the intricacy of the thought process of making the elements join. And I think the complexity is a big issue.
Yes, it is. One of the things with this experiment we're about to conduct with this little building that I showed you is there is a difference in how you build a model when the structural engineer, the mechanical engineer, the fire consultant are all going to use that model or a copy of that model as well. And it's going to change the way we do that work. It's going to change the level of detail that we use quite considerably. So the basic issue that you're raising is going to get worse before it gets better. A lot of that, Revit is capable of carrying all of the data that you need to represent everything at whatever level you need. The problem is the hardware that you're running capable of dealing with all of that data?
I've heard that several times before. I don't think that's a good excuse.
No, it's not an acceptable excuse, but it is a real situation. So, there's a couple things that are happening with that. One is, as I was just mentioning, what happens with 64-bit computing, where we are able to access multi-core and multi-processor systems. So the software itself is not waiting for the hardware. And then the issue of, well, why is this not working, falls back on the head of the software. And in the software, how do we deal with this sort of thing? But to my mind, it's more a question of having hardware and reducing the bottlenecks in the system for getting information that you're carrying between different areas, whether it's the screen for us to look at or the printer or whatever it happens to be. You can create a window family that has different sills and heads, that has at a coarse level of detail just a simple little rectangle and single line to represent the window, and at medium it has the profile, base profile of the window jambs, and at fine detail it actually has the manufacturer's profile straight off their website loaded in it. So the program will carry all that data. It's just, I suppose what you're really saying is that you're having to wait too much for it, right? It's slow.
I'm saying that the conceptual approach of AutoCAD is not influenced by the size of the files in the directory on the computer.
Correct.
Just the file that you're working on.
Yes.
Whereas working with Revit, you're working on any part of it is affected by the size.
Everything else. Yes, that's right.
And so, like in a dialog box where you want to click 3 things, and it has to consult the model on each one.
Yeah.
It seems like there's a conceptual problem.
Yeah. One of the examples I've used in training classes before is going into an elevation of a 15-story building, grabbing a band of windows, copying it and pasting it up to the next level. Now we do that in AutoCAD, so we're in a drawing that maybe has just the elevations, perhaps sections in it. And the copy and paste process happens so quickly you effectively can't time it. You turn around and with the same building design do that in Revit, and it takes, I don't know, let's say it was 10 seconds to do it. And people think, well, holy shit, what am I going to do here? I mean, I can't sit around and wait for this all the time. But then you say, well, what did AutoCAD do and what did Revit do? Right? AutoCAD moved a series of independent lines that were in a particular position up into a new position. And that's it. It has no meaning beyond it being a series of lines. In Revit, I've now adjusted my elevations, my plans, my sections, my 3D, my walkthroughs, my scheduling. You know, everything's been done. All right, well, if that's the case, let's turn around back to the AutoCAD file and do those things and get all of that stuff up to date and coordinated to our elevation file. How long has that taken me?
10 times more.
Yeah, and that's going to take me 15 minutes. So there's definitely a perceptual change required in the way you interact with the software with something like Revit. To say that it's looking after so many things in the background for me that these aspects, I do have to wait for the computer for that. But nevertheless, the time it's taking where I have to wait is doing far more than I could have done in that time.
Why not have it do that in the background and let you continue working?
Well, it is doing that in the background. Yes, see, it is doing it in the background, and that's why I was talking about the hardware, because the hardware is not, the software has gotten ahead of the hardware. So the hardware is not able to keep up. The background processing is what's slowing down the foreground work that you're trying to do at the same time. So as the hardware increases, that overhead required by those background processes will be reduced. Or at least I believe so. Yeah. Any other questions? No?
You're right on time.
Right on time. How about that? That's a first.
So, all right. Wes, obviously we'd like to thank you for giving us a nice presentation here. Yeah, again, feel free to stick around, but I'd just like to say thanks to you know, our office services crew here at SOM for setting all this stuff, and Kathy Borg is our digital design assistant admin that really kind of was the force behind our food and everything else. Thanks to Autodesk for buying us dinner. Unfortunately, nobody is here to represent them. You know, everybody's on vacation. Jordan DiMartino's on vacation. James Vanderzand's on vacation. So I have no prizes to give away today. Sorry. Normally we do. We usually give out full seats of Revit. So that's an incentive to come back next time. Again, when Autodesk is...
But you had pizza.
We had pizza, yeah, but that's our standard fare. Maybe next year, next time we'll step it up a notch. So again, Wes, thank you so much for coming out. I hate to have you run, you know.
Not a problem.
But I know you have to get out.
No, I'm glad I could catch up.
Again tomorrow, right?
Yes, do this tomorrow. Yes.
You're speaking at the
Yes, Southern California.
Yeah.
Yeah, and then in Seattle on Friday.
So again, let's give Wes a big round of applause.
Thanks very much. Thank you.